Hi Crocs, it's Dr. Z here. You recall in previous week we talked a lot about magnets, and we talked about temporary magnets and permanent magnets. And you recall that a special type of temporary magnet is called an electromagnet, one that you can switch on and off. Now scientists have learned how to use electromagnets to actually do work for us. And they were able to convert electrical energy into mechanical energy. And mechanical energy means work. So they were able to convert electricity into actually devices that will do work for us. One of these devices is called an electric motor. And again, electric motors are everywhere in our lives. They do a lot of work for us. They can be very small and they can be very large. But I have a couple of demonstrations here which hopefully makes it helpful to figure out how does an electric motor really work. And here's a very interesting one that I can do. As you might be able to see here, I have two sewing needles that I put into this wood, kind of needles that your mom uses sometimes to sew things, okay? And these sewing needles are made out of iron. And as you can see, I have them connected with these alligator clips to a box containing some batteries. And what I did was I made a little coil like this. I just wrapped some copper wire around a cylindrical object, and then I tied the wire around the coil, and I have two ends of the wire, and I actually put those two ends in between the sewing needles. So now here I have some of those neodymium magnets we talked about that are pretty strong magnets. Now as you can see, as I bring the magnet here close to the sewing needles and this loop of wire, nothing much is happening, okay? Now let's turn the electricity on. And as you recall, electricity now is going into the sewing needle, and then it's going through my copper coil here, and then back out of this this sewing needle and back into the battery. So I have an electric current flowing through this whole system here. And now something interesting happens. Let's see, as I bring the magnet closer and closer here, sometimes this needs a little coaxing. But as I bring the magnet closer and closer, as you can see now, the coil is beginning to spin, okay? And it takes a little doing, but you can get that coil. There it goes. It's going really fast now. So what I've done is now I've converted electrical energy from the battery into mechanical energy, the spinning, by using a magnet and the copper wire, right? And let's pretend that I had two wheels on either side of this copper coil. I would have wheels turning around, and I'd have an electric car. And that's kind of the general idea about how an electric car works. Okay, so this is just a very simple way of understanding how electric motors actually work. Here's another one that's really fun. I took a AA battery here, and I took some more of my neodymium magnets. I put them together, and then I have a piece of copper wire here. I'm going to turn this off. That kind of looks like a heart. It has a little dimple at the top here, and I'm going to put this on my. And look at that. Whoops. It's going so fast. Okay. But you can see that copper wire is really spinning fast. And that's because of the electromagnet that I'm making here using the battery and the copper wire, okay? So very simple way of showing how electric motors really work. Okay guys, thanks for listening. Have a great day and keep doing your science. See you soon.